Okay, hey everybody, after 2 tries, let's try this again, the 3rd try. Okay, welcome to Video Notes. So today we are going to be talking about the hypotenuse leg theorem. Now, this theorem can only ever be used for right triangles and right triangles only. Okay, so if you are looking at 2 right triangles, you could use the hypotenuse leg theorem. However, if even one of your triangles is not a right triangle, you cannot use this theorem. Okay, let's go ahead and talk about what exactly the theorem is. Okay, well, in a right triangle, let's first talk about what the sides are. This longer side we know as the hypotenuse. Okay, so that is Hypotenuse. Okay, that marker is done so. Okay, so that is the hypotenuse. That is our long side. Well, what are our 2 shorter sides then? Well, to every right triangle, you have 2 legs. So you have 1 hypotenuse, 2 legs to every triangle. Now, with this theorem comes 3 conditions. The first one, there are 2 right triangles. Okay, again, if you do not have 2 right triangles, you cannot use the hypotenuse leg theorem. Next, the triangles have congruent hypotenuses. Okay, so our hypotenuses, the long sides, they have to be congruent. If they are not, you cannot use the hypotenuse leg theorem. Lastly, there is 1 pair, exactly 1 pair of congruent legs. So the 3 conditions are there 2 right triangles, yes or no? Are the hypotenuses congruent? Yes or no? Is there just 1 pair of congruent sides? Yes or no? Over here, notice all 3 of our boxes are checked. These are 2 right triangles. Our hypotenuses are congruent. And we have 1 pair of congruent legs. 1 pair of congruent legs. So I could say that these 2 triangles are congruent to each other. How? The hypotenuse leg theorem. Let's go ahead and start identifying when the hypotenuse leg theorem is actually being used, though. So on the next page, we have a couple of examples. On this page, you are told, hey, these are already congruent. You've been told that. Let's find some missing sides. Let's go ahead. We're going to do numbers 1 and 3 together. I need you to do 2 and 4 on your own. Okay, so I'm going to do numbers 1 and 3. I need you to do numbers 2 and 4. Okay, well, remember, using the hypotenuse leg theorem, if these 2 triangles are in fact congruent, by the hypotenuse leg theorem, then our 2 hypotenuses need to be congruent. Well, if this hypotenuse is 17, that means for this one, x has to be 17. Okay? Number 1, pretty straightforward. Number 2, the exact same thing. You just have to figure out, is that side, is x 4.25 or is x 3? Next, number 3 here. Well, okay, we're not really given any numbers. But I do know that this x plus 3 and this 3y need to be congruent to each other. So I'm going to set them equal to each other. Why am I doing that? It's going to happen eventually. I know they have to be exactly the same, so let's go ahead and set them equal to each other first. Next, I have my 2 legs here. These legs also need to be congruent. So I'm going to set x equal to y plus 1. Then, here, you should notice when I have x is equal to something, I can now use substitution. Okay, so if I substitute out this x for y plus 1, this gives me y plus 1 plus 3 is equal to 3y. If I clean this up a little bit, this gives me y plus 4 is equal to 3y. If I move this y over to that side, this gives me 4 is equal to 2y, leaving me with y is equal to 2. Okay, that's good. I found half of them, y is equal to 2. And then I know that x is whatever y is plus 1, so that means that x is 3. Okay, so y equals 2 and x equals 3 are my two answers. Number 4 is going to be something similar. Might be one extra step, but I'm more than confident you guys should be able to handle that. Okay, so let's go ahead. Last thing we need to do is do a proof. Okay. So let's talk about this proof. Oh, sorry, almost skipped a step. So here are two more examples. You need to tell me, hey, is there enough information here? Number 1, notice these are two right triangles. We have our pair of congruent legs. However, our two hypotenuses. Since we are not given that they are congruent, we cannot assume that. So this one is a no. Why is it a no? Well, our hypotenuses aren't congruent. Okay? Just because they look the same, just because they feel the same, just because they sound the same, doesn't make them the same, doesn't make them congruent. Okay? So number 1 is a no. Now, number 2 here, it is also a no. I need you to figure out why. Are these two right triangles? Are our hypotenuses congruent? Do we have one pair of congruent legs? Okay? No. What are we missing? What are we missing? Okay? So, now, let's go ahead and get into this proof. So, this proof, wow, looks like a lot. Let's start with our given. We are given that GKE, okay, this triangle is an isosceles triangle with a base of GE. Well, if my base is GE, that means that GK is congruent to KE. Why is that? GK is congruent to KE. The reason, this is the converse of the base angles theorem, or BAT for short. Okay? The converse, okay, I know it's kind of hard to see. I can't really get rid of that glare. Okay? The converse of the base angles theorem tells me that my two sides here need to be congruent to each other. Okay? There's one. Next, we know that both L and D are right angles. Well, hopefully, you know that right angles are always 90 degrees exactly. So, we can say that angles L and angles D are congruent. Why? that's given to us. Is it really given to us? No, kind of not. It's kind of given to us in a kind of backwards way a little bit. They give you the definition, and then you just need to say, okay, well, just because they're both right triangles doesn't mean I have to list that. I just need to say, hey, they are congruent to each other. Why? They're both 90 degrees. Okay, so notice also I kind of went out of order here. Usually given goes first, but I was given this as well. So technically I'm not out of order, but it doesn't really matter if your givens go first, to be honest. Okay, I always like to list them first. This case I didn't, not a big deal. Now, we say that K is a midpoint of this line LD. Well, in order for something to be a midpoint, it has to be sitting directly in the middle of the two other points. Okay? Well, notice K is sitting right in between L and D. So what I can say is that LK and KD are congruent to each other. Why is that? Well, that's the definition of midpoint. In order for something to be a midpoint, it has to be directly in the middle of that line. It needs to be cutting that line directly in half. That is literally the definition of midpoint. Okay? Well, so we're here. So I have two right triangles. I have two congruent hypotenuses. I have two congruent legs. There's the HL theorem. I have my two congruent legs. I have my two congruent hypotenuses. And they are both right triangles. So here's what I'm going to say. Triangle G, L, K is congruent to triangle E, D, and K. Why is that? That is the HL theorem. Well, that's fine and all, but notice I still haven't proven what I wanted to. I needed to prove that LG was congruent to DE. That is these two sides right here. Well, remember back to congruent polygons. Okay? If I were to take GLK right here and reflect it, I would notice that LG and DE are a corresponding side. So I can say that LG is congruent to DE by the definition of congruence. Okay? Since they are corresponding sides, they have to be congruent. Okay? That is all I have for you today. Please make sure to bring in your notes on Monday, as I will be checking those for your homework for Chapter 5, Section 5, Part B. Okay? Have a good weekend. I will see you guys on Monday. See ya.